In this video, I'm going to talk about motor torque basics. I have a sequence on my left here, and then I have a diagram of a motor on my right. So let's get into it. Let's talk about step one, stator field direction. So over here we have the stator of a three-phase, two-pole motor. Those basics have already been introduced in previous videos. And I'm going to do an ABC rotation. So what happens is the stator field, in this case, is going to move clockwise. So that's the stator field direction. We just have to be aware of that. That's step one. Step two, because of this stator field moving, or the magnetic field moving, it's going to cut across these rotor conductors. So here we have a rotor conductor, and here's another rotor conductor. There's more, but we're just going to focus on these. Now, we also have to establish magnetic field orientation. I'm going to say this is North Pole, this is a South Pole, which means the magnetic field is going down. Now, what we have is a magnetic field cutting across a conductor. At this point in time, the conductors are stationary, so we have relative motion between this magnetic field and this conductor, which now we can apply the left-hand generation rule. Before we start, the left-hand generation rule, the thumb means thrust or physical movement of the conductor. In this case, the conductor is actually not moving. It's a magnetic field that's moving. So we have to add an extra step. The magnetic field is going from left to right. That is like the conductor going from right to left. And it would be in the opposite direction for this one. The magnetic field is going this direction. It's like the conductor going that way. Okay, so now I have the thrust represented here. Just want to state one more time, the conductor is actually not moving in this direction. It's the magnetic field going in the opposite direction, but the relative motion is indicating it's like the thrust of the conductor going in this direction. Now we can apply our left-hand generation rule. Forefinger going down, the thrust of the conductor going to the left, which induces a current into the board. In this case, magnetic field stays the same. The thrust is going to the right, and then we have a magnetic field induced coming out of the board. I'm going to erase these arrows now. They have done their work. And now we still have our stator magnetic field going around the motor, and now we have an induced current into the rotor conductors. Let's look at step three. Magnetic field around the rotor conductors. And here we use the left-hand conductor rule. So we have our current. Left-hand conductor rule says that the magnetic field around this conductor is in this direction, and the magnetic field around this conductor is in this clockwise direction. That's all we have to do for step three. Step four is the interaction between the stator field and the magnetic field around the conductors. So, just erase these arrowheads here. We know that they're there. So what's happening is the North Pole of the stator still wants to find the South Pole of the stator, but the conductor magnetic field is in the way, and it's going to move the magnetic field of the stator to this side because of the direction there. And then that's going to continue down, and then it's going to pull the direction over that side and then find its way to the South Pole. Of course, it's not just one line of flux. There's a bunch of them. I'll draw three just to represent, and that's the direction. Now, what happens when you bend a magnetic field like this? There's some tension there. And in this case, it's going to come out as torque. And a way of thinking about it is this, if this was a string and I was pulling this string tight, does it make sense that there's going to be a force on this side of the conductor going from, in this case, left to right, and over here from right to left? And that's what is happening, is these magnetic fields, they want to straighten out. And with that straightening action, they're going to put a force on one side of the conductor and push it in this direction. So we have, because these rotor conductors are on a rotor that spins around, we have torque going in a clockwise direction. So the torque of the rotor actually follows the same direction as the rotor, or sorry, the stator movement. But we need all these rules to really find that out. Now, so that's basically the direction of torque using the left-hand rules. Just want to use one more check with my right-hand motor rule. Now the right-hand motor rule, all the fingers use the same concepts as the left-hand generation rule. It's just thought of a little bit differently. So what's happening here is we have magnetic field, forefinger, we have a current of the rotor conductor, and those are going to show us which direction motor torque is in. So let's use this one as an example. So field is going down, we have a current going into the board, then the thumb shows that the torque direction is to the right. Over here, magnetic field still going down, we have a current coming towards us, which then the thumb shows us the direction of torque is from right to left. So the right-hand motor rule is just confirming everything that we already did over here to show us that the torque direction is clockwise. There you go, there's some motor torque basics. We'll see you in the next video or in the classroom.